All right, in this video, I want to go over a worksheet from section 3.3, constructing bootstrap confidence intervals. And here we're given a random sample of 10 textbooks, rounded to the nearest dollar at their sale prices. Maybe you're thinking these are too low for some of your textbooks, but we also have that variability when we do random samples. So I want to go through this and first figure out, well, what is the sample mean going to be? So I could add up all these numbers together and then divide by 10, because there's 10 textbooks. That'd be perfectly fine for the sample mean. I'm going to go to stat key, one quantitative variable. And here, click on the edit data. So highlight all of this, delete it. And then what I could do is just enter in my data here if I wanted to. It's just a different way of getting the average, getting all your summary statistics. 32, 87. Through here, put all those numbers into stat key. 185, 52, 23, 147, 125, 93, 85, 72. And then click OK. Let's see, let's make this a little smaller. So I enter those in, and here we go. We have a bunch of summary statistics, the sample size, mean, standard deviation, 5-number summary. This problem, we're just looking for the sample mean, 100.1. So go back here. I want to use proper notation on this. Let's see if I can get a different color. So for sample mean, don't forget that is X bar, or X with a line on top of it, is 100.1. And that would have the same units. So I'll say $101.10 is your average. Okay, so the next question is, how would we use cards to create one bootstrap? So we would need 10 different cards. You could take maybe ace, 1, 2, so on to get to 9 if you wanted to. That would be 10 different cards. And each of these cards would represent one of these let's say textbook prices. So as an example, let's say the ace is going to represent 132. 1 is going to represent the 87, etc. All right, and then what you can do is shuffle these cards. And pick one card, write down the value, replace the card, shuffle, pick again. And you'd want to repeat this to get 10 cards. So the idea is you have 10 cards here, and they all represent 10 of these textbook prices. You shuffle that, and you're going to end up picking a card, write down the value, but then the main thing is replacing that card. You want to replace that card, put it back in, and reshuffle. So one possible bootstrap sample could be, say, you get 87, and 185, and 23, and then 52, and then you get an 87 again, 72, 85. And we want to make sure you have 10 cards. So 1, 2, 3, 4, 5, 6, 7. Take another 147. And let's say you get 87 again. 93. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cards. They all come from the sample, but notice I did get 87. Possible to get a card more than once, or we didn't get, say, 125, because that's the idea of randomly picking values from here, but with replacement. So you might not get the exact same sample. right. And the bootstrap distribution, don't forget, that is if we were to go through this process many times, maybe thousands of times. This here would just be one bootstrap sample. Recall a bootstrap distribution is the sample means of many, many bootstrap samples. So we'd have to repeat this process over and over again. If we were to do that, this would be centered around 100.1. It's going to be centered around the sample mean, and the shape will be symmetric and bell-shaped. So we'd have a symmetric and bell-shaped curve. All right, the next question is, suppose we have another sample here, 8, 4, 11, 3, 7. Which of these following four could be a bootstrap sample? Now I'll put a little explanation. So maybe explain why or why not. Explanation. We take this first one, 8, 3, 7, 11. They all come from the sample, all those values, but this is not a bootstrap because the sample size differs from the original sample. For the original, we need to have exactly 5. What about B? I want to look at a couple things. The sample size is the same. They both have 5. And the numbers are all the same. They match up. So this could be a bootstrap sample. All right, part C. 3, 4, 5, 7, 8. So we have 5 here, so that's correct. But this is not a bootstrap sample. And why not? Not a bootstrap sample because 3 is on the list, 4 is on the list, 5. 5 is not in the original sample. All right, we're taking the original sample and just shuffling it around. So we can't have 5. And the last one we have 7, 8, 8, 3, 4. Same size as the original sample, and all those numbers come from the original sample. So this could be a bootstrap. Cool. Let's make this a little bit bigger. Okay, so on number 3 here, what percentage of Americans believe in global warming? A survey of 2,251 randomly selected individuals conducted in 2010 found that 1,324 answered yes to the question, is there solid evidence of global warming? We are given a bootstrap sample here below. Use this information to give and interpret a 95% confidence interval for the proportion of Americans who believe there is solid evidence of global warming. All right, okay, so let's go down here. Let's first note what is going to be the center of the 95% confidence interval is the sample proportion. And right here, given in, if you took 1328 divided by 2,251, you're going to get, I'm going to say approximately, because this is rounded, 0.59. So this will be the center of the confidence interval, the statistic. And where we use this randomization distribution for is to get the standard error. The standard error is the standard deviation, the bootstrap distribution, which given here is the standard deviation 0.01. So we've got the center of the confidence interval, we've got the standard error given this randomization distribution. And notice this won't always be the exact same thing. If I were to go back to say stat key, I could create a confidence interval for a single proportion. Click on that Edit Data button. It's 1328 out of 2251. So notice right here I have the same sample proportion, and if I generate a couple thousand more samples, here we go. Standard error is given to be 0.0110. Let me go through this one more time. If you're on the main stat key menu, we're looking at confidence interval for a single proportion. Edit data, and this is our sample proportion, our p-hat, 1328 over 22501. Click OK. Make sure the proportion matches up, our sample proportion. And generate, I like to generate at least 2,000 samples. Notice here the center of this distribution should be, if not the exact same, very, very close to the original sample statistic. But we're looking here specifically for this standard error. All right, then the margin of error for a 95% confidence interval is twice the standard error. So say margin of error equals 2 times the standard error, so 0.02. And lastly, 95% confidence interval is going to equal, I'm going to write it like this, p-hat plus or minus 2 times the standard error, which for this is going to be 0.59 plus or minus 0.02, since we already calculated the margin of error. And that's going to be, if we subtract 2, 0.57 to 0.61. So it's calculating the confidence interval, 57 to 61. Now the interpretations, I think a little bit trickier. I want to give a good interpretation for this. So we are 95% confident that the proportion of Americans who believe there is solid evidence of global warming is between 57% and 61%. All right, and we'll look at one more question, one more example on the next video.